Today we would like to discuss about soil nitrogen, available soil nitrogen by subbiah and asija method. They developed this method in India first time in 1956 for Indian conditions. They developed this test by easily oxidizable by digesting easily oxidizable organic matter and adsorbed ammonia by replacing with sodium hydroxide. They used alkaline permanganate method, alkaline permanganate for oxidizing the easily oxidizable organic matter and sodium hydroxide, sodium hydroxide to replace the adsorbed ammonia and the soil particles. Both ammonia particles they will be liberated in the distillation flask and they will be absorbed in boric acid, 2% boric acid medium along with mixed indicator. Here mixed indicator is used to know the ammonia. When ammonia comes, it turns green color. Means in alkaline conditions, it turns green. So we can easily estimate by this indicator how much ammonia is absorbed in this boric acid. So in this method, what we'll do is first we have to take 20 grams soil, air dried soil, in a 500 ml distillation flask. Here we add 100 ml of 0.32% potassium permanganate and 100 ml of 2.5% sodium hydroxide and some glass pads and some wax to stop frothing. So then another end in distillation set at the end of condenser, what we have to use, we have to put 25 ml of 2% boric acid along with mixed indicator. Here in this mixed indicator, we'll mix methyl red and bromocresol green. Both indicators will be mixed. At the beginning, it will be like wine red color. This mixed indicator along with boric acid, it will be in wine red color. After absorbing ammonia, what it turns into green color. Green color. So what we have to do, slowly we have to heat it. Heat this distillation. First we have to take 20 grams soil in a 500 ml distillation flask, add 100 ml of 0.32% potassium permanganate and add 100 ml of 2.5% sodium hydroxide and some glass beads and some wax to stop frothing. So then after completely setting the distillation set, close the each and everything. And another end of this distillation set, at the end of condenser, you put 25 ml of 2% boric acid along with mixed indicator. Then you start heating, gently heating. Generally, we use 1000 watts heater coil. If we use 1500 watts, generally what happens in the middle that coil will be burned and it stops middle and it creates problem. So generally gently we have to distill it. So we have to use 1000 watts in 1000 watts coil. You don't get this problem, so slowly we can heat it. So try to get to 1000 watts coil for heating this distillation plus. So heat the contents up to 30 minutes so that approximately we will collect 150 ml distillate. During distillation, ammonia is liberated due to reaction of ammonical compounds with sodium hydroxide and simultaneously this potassium permanganate 0.32% potassium permanganate oxidizes the readily oxidizable organic matter. At that time, some amount of nitrogen present, it will come as ammonia from the organic matter, and that organic matter and already present in on clay mycelium, some ammonia will be there. That ammonia also will be liberated by addition of this sodium hydroxide. Sodium hydroxide replaces the ammonia, and the ammonia in gaseous form it will be distillated along with water. Then it comes to condenser and it will be cooled with water and it will be absorbed in boric acid medium. When it comes into boric acid medium, that boric acid, wine red color of the boric acid slowly turns into green. So after half an hour, just you remove. So try to see at least 150 ml of distillate comes, then stop the distillation, and then that if you observe the color of this distillate, it will be like green color. So what we have to do then, after cooling, just slightly cool it. After cooling, you titrate this boric acid, green color boric acid, with 0.1 normal or 0.02 normal. Any type of standard sulfuric acid, means diluted standard sulfuric acid, we can use it. Then titrate it. Then in titration, what we will observe slowly after titrating, again this boric acid, the green color boric acid, will become wine red at the end point. So you stop it, then note down the title value. Some title value will come. So that is the amount of ammonia absorbed in the boric acid. So after that, we have to calculate how much ammonia is there inside the soil. So this method was developed first time by Subbiah and Asija in 1956 in India, in soil testing laboratories, in our soil testing laboratory, IRA. Calculations means now we completed the distillation for available soil nitrogen. Then now we have to calculate. We titrate the already distilled ammonia with standard sulfuric acid. We can use 0.01 or 0.02. Now here we are using 0.01, means 1 by 100 normal sulfuric acid. Then how to calculate the amount of nitrogen in the soil by this method? Now we got titrate value. We titrated the distillated ammonia by standard sulfuric acid 0.01 normal. Now we are calculating. Amount of soil taken for distillation is 20 grams. Next we used 0.01 normal sulfuric acid. Now we have to think, this sulfuric acid, how much amount of sulfuric acid will react with how much amount of nitrogen. Here equation is there. Suppose if we take 0.01 normal sulfuric acid, that means 1 ml of 0.01 normal sulfuric acid, it reacts with 0.14 milligrams of nitrogen. Then now we have titrate value. We got a titrate value of 10 ml in this method. Example, this is one example how to calculate amount of nitrogen present in the soil by Subbiah asija method. Here in this method we got 10 ml of titrate value, means this 0.01 normal sulfuric acid reacted with already distillated boric acid along with mixed indicator. We got 10 ml titrate value. Now 1 ml of 0.01 normal sulfuric acid is equal to 0.14 milligrams of nitrogen. Then 10 ml of 0.01 normal sulfuric acid is equal, we have to multiply this factor with 10. 10 into 0.14 milligrams nitrogen, that is equal to 1.4 milligrams nitrogen. Now this distillate came from 20 grams of soil. We have taken 20 grams of soil. So this amount of this 1.4 milligrams of nitrogen present in 20 grams of soil. So we have to calculate for 1000 grams of soil. Amount of nitrogen present in 1000 grams of soil is equal to 1.4 milligrams by 20 into 1000 milligrams. So we get about 70 milligrams nitrogen. 70 milligrams nitrogen per 1000 grams. So here one factor is there. 1 ppm is equal to 1 milligram per 1 kg. So we got here 70 milligrams per 1 kg soil. So it is indirectly nothing but 70 ppm. Now we got a value of 70 ppm because the amount of nitrogen present in 1 kg of soil is 70 milligrams. So milligrams per kg is nothing but ppm. So we got 70 ppm. Okay. Now another thing is, now we got the value in terms of ppm, but we have to convert into percentage. Here factor is 1% is equal 10,000 ppm. So you have to divide this ppm with 10,000, then you will get the answer in terms of percentage. Now 70 by 10,000 ppm equal to 0.07%. Therefore, amount of nitrogen present in soil in terms of kgs per hectare is equal to 70 ppm into 2.25. Do you know how we get this factor 2.25? ppm into 2.25 is equal to kgs per hectare. How we are getting here? One factor is how we will get this factor when we get results in terms of ppm. If we multiply this ppm with 2.25, we will get results in terms of kgs per hectare. How this is happening? Here the thing is, we are calculating the soil up to 15 centimeters depth. We are calculating the nitrogen up to only plow layer. Plow layer means only 15 centimeters depth. Up to 15 centimeter depth, how much nitrogen is there in the soil we are calculating. First we have to calculate how much soil will be there up to 15 centimeters depth. 15 centimeters depth. 1 hectare area. 1 hectare area is equal to 100 meters into 100 meters. Here 15 centimeters convert into meters, 0.15 meters. Then if you calculate the volume and if you multiply that volume with 1.5, generally we'll take the density, bulk density will take as 1.5 grams per cubic centimeter, 1.5 gram. Then if you multiply this volume and this density, you will get in kgs. Means we'll get the weight, we should convert into kgs. Then if you calculate all these things, you will get 1 hectare area up to 15 centimeter depth topsoil with a bulk density 1.5 grams. You will get a soil weighing about 2.25 into 10 to the power of 6 kgs. This also we can show, but you remember this point. 1 hectare area with 15 centimeters depth with a bulk density of 1.5 grams weighs 2.25 into 10 to the power of 6 kgs. This also we can tell how we'll get this, but I think you can understand how you will get this figure. So don't worry about this. So amount of nitrogen present in soil is equal to, here ppm into 2.25, we got a ppm of 70 ppm. So 70 ppm into 2.25 is equal to 157.5 kgs per hectare. Our available soil with this subbiah asija method, we got 157.5 kgs per hectare. Means this amount of nitrogen is present on plow layer. 15 centimeters. Plow layer means 15 centimeters. Okay. Then we got the values. Then we have to see whether it is low, high, or medium. A rating chart will be there. We will discuss about rating chart now. This is the rating chart for available soil nitrogen estimated by subbiah asija method, potassium permanganate method, alkaline potassium permanganate method. This is the rating chart here is low, less than 250 kg per hectare available nitrogen. If it is 250 to 500 kg per hectare, it is medium. If the available nitrogen is more than 500 kg per hectare, that is high. Here, this available nitrogen plow layer, up to plow layer means 15 centimeters depth. So low is less than 250 kg per hectare, medium 250 to 500 kg per hectare, high more than 500 kg per hectare. Now we calculated manually, but we also wrote a program in Excel and C++. We'll see those programs also. This is a Excel program for calculation of available soil nitrogen estimated by subbiah and asija method. Here we are taking 20 gram soil and we are using 0.01 normal standard. Any acid we can use means either you can use 0.01 normal or 0.02 normal according to we can calculate, we can get the results. Here we developed the Excel program. Here you can see columns A, B, C, D, E, F, 1, 2, 3, 4 this lines, columns and rows. So in fifth line means in first A column we have given serial number, B column parameters, and G column values results, and H we explain the formula how we got this result. In H we have given the formula. If you incorporate this formula, you will get this result. So you see this formula, if you put in this G, you will get this value. So first statement, amount of sample, here 20 grams we have taken. Second statement, concentration of H2SO4 we have given G7, and the title value of the distillate we have given in G9. Title value here we got to 10 ml. And nitrogen content, now we calculated nitrogen content in percentage. Here in G11 we have given, we got to 0.07. How we got, this is the formula. In this G11 we have income, you slightly type is equal, then you type this formula, then you will get this answer 0.07. And in 13th column, in G13th we got ppm, nitrogen content ppm. How we got, this is means this percentage multiplied by 10,000, because ppm into 10,000 is equal to percentage into 10,000 is equal to ppm, means 1% is equal to 10,000 ppm. That's why we are multiplying this percentage with 10,000. So here in ppm means G13 we use this formula, G11 into 10,000. Star mark is into. Next in 15th column, nitrogen content kgs per hectare, means it came G15. Here we got 157.5 kgs per hectare. How we got? We used this formula. Next we have written is equal to G13 into 2.25. If you write this formula here, you will get this answer. So we are calculating kgs per hectare finally available soil nitrogen by subbiah and asija method. So if you type this formula, this program, if you make in your Excel sheet, you can get easily, you can calculate again and again. In the fast manner we can calculate, then you don't get any error or trouble or anything, and calculation also faster. So this program will be useful when you do soil analysis for nitrogen by subbiah method. And also another program also we have written in C++, that also we will see. This is the program for calculating available soil nitrogen by subbiah method, and you can also calculate plant nitrogen also. When you do plant nitrogen also, you can do for both plant nitrogen as well as for soil nitrogen. Subbiah assay method. I wrote a program in C++. This is the script. When you get this executable program by this method, if you write this script in Excel program, you will get the executable program. Then you can use that program and you can do it. Soil available nitrogen by subbiah assay method. This is the thing. These are the different steps in writing the program C++. This I wrote at my laboratory. You can also write in the same manner by using different steps. You can modify and you can use. This is one example how I wrote a program for C++. You can modify and you can, according to your situation, you can modify certain things and you can write a very good program in this C++. So anyhow, that Excel program very simple. We can use it, or if you have time, you can write this type of programs for calculating the analytical results. Thank you very much.